Welcome to Group Properties of Fluids. There are many properties of fluids, but in this video, we will just only discussing its density and its viscosity. Under the density, we have three subtopics, namely the mass density, the specific density, and the relative density. Under viscosity, we have the coefficient dynamic viscosity and the kinematic viscosity. So, hi, I'm Jamaica Guittu, the first reporter of the properties of fluids under the density, the mass density. But before we go to our discussion, we will be having an experiment for us to be understood what density is. So in these experiments, we have different kinds of liquids and solids. I here with me is an oil and water, and solids I have these grapes and a penny. And so
ipas ko.
Tignan natin kung hindi. Whips. And plastic bag. So, in this experiment that we conducted, napansin natin na iba-iba ang density ng solid at liquids na ginamit natin. Nung binuhos natin ang mantika kanina, akala natin maghahalo sila ng tubig pero hindi. Bagkus ay pumunta siya sa ibabaw ng tubig. At nung nilagay naman natin yung mga solids gaya ng piso, lumubog siya. At yung grapes, lumubog siya sa may tubig. So, ibig sabihin yan, mas dense yung grapes at piso kaysa sa tubig. At nung nilagay naman natin yung plastic cup, akala ko kanina talaga mag-float lang siya, pero hindi. Lumubog siya sa may mantika. So, ibig sabihin yan na mas dense yung plastic cup kaysa sa mantika. So, ibig sabihin, ang density ng isang bagay ay ang relationship sa mass nito sa volume nito, or kung gaanong karaming space ang ino-occupy ng isang bagay. Nakadepende ang density ng isang bagay sa mass, sa laki nito, o sa pagkakapwesto ng mga atoms o molecules nito. Nabanggit ko kanina na ang density ay ang relationship nito sa mass nito sa volume nito. So, we define the density as it is the amount of the matter within a certain volume, or refers to the measurement of how compact an object is, or how tightly compact or how heavy the molecules are in the object. And mass, measurement of the amount of matter or stuff in an object that is measured in grams or in kilograms. Sabi na dito, measurement of the amount of matter. We have three states of matter: the solid, liquid, and gas. And the volume, measurement of the amount of space an object takes up, that is measured in cubic centimeters and the cubic meters. So, ang volume, ito yung nagme-measure kung gaano karaming space na titake o ino-occupy ng isang bagay. So, mass density or density, commonly called as density, is defined as the mass per unit volume. So, this is the formula for the density. P, or we read this symbol P as rho, equal to the mass per volume. Although we can use the symbol D for the for density, pero mas baka malito tayo kasi di ba? Symbol D is also for distance. So, so we use the letter P, or we read it as rho, as equal to the mass over the volume. Remember the units for the density. Mass density is the gram per cubic centimeter or gram per cubic meter. The basic unit, basic SI unit for the density is the kilogram per cubic meter. So, example of density. These two objects are in equal volume but different in mass due to their density. We know, parehas silang equal volume in cube, pero alam naman natin na mas mabigat ito kaysa dun sa isa. Diba? Sabi nga natin kanina na ang density, it measures how compact an object, the molecules in an object meter. So, sa density, itong formula, di ba? Pero pwede natin i-derive itong formula ng density kung ang hinahanap natin sa isang problem ay ang mass o ang volume nito. So we can derive the formula for density kung hinahanap natin ay mass. Halimbawa, hinahanap natin ang mass. So P over V. Ito yung original formula for the density. So, gamitin natin yung triangular formula. Sa taas nito ay ang M. Sa baba nito ay P. Yung rho, or yung density, and the V. Pag hinahanap natin ay ang mass, M is equal to density multiplied by its volume. T over V. And the units for mass is in kilogram or in gram. At kapag hinahanap naman natin ay volume, ito, V is equal to M mass divided by the density. And the unit for volume is in the cubic centimeter or in cubic meter. So let's have an example on how to compute density. Example number 1. If the mass of an object is 35 grams and it takes up 7 cubic centimeter space, calculate the density. So we have the mass that is equal to 35 grams. And the volume is 7 cubic centimeter. So, ang hinahanap natin ay ang density. So, the formula for density is P rho is equal to mass over the volume. Mass is equal to 35 grams divided by 7 cubic centimeter is equal to 35 divided by 7 is equal to 5 grams per cubic centimeter. So that is the mass of an object in 35 grams that takes up 7 cubic centimeter. So another example number 2. A 300 cubic centimeter oil weighs 173 grams. Compute the mass density of oil in kilogram per cubic meter. So kukunin natin ang density ng oil na nasa basic unit na kilogram per cubic meter. We have the volume na 300 cubic centimeter and the mass na 173 grams. So, kailangan natin i-convert yung cubic centimeter sa cubic meter at ang gram sa kilogram. So, time multiplied by, alam naman natin na in 1 meter, in 100 centimeter, we have 1 meter. 100 centimeter, we have 1 meter. So, pero hindi naman natin makakancel yung cm tsaka cm kasi nga naka-cubic. So, kahit maglagay tayo ng close sa parenthesis dito, lagyan natin dito ng 3 is equal to 300. So, is equal to 300 cubic centimeter times by 1 cube is equal to 1 meter cube is equal to 1 meter cube, and 100 centimeter cube or 1,000 times 100 times 100 times 100 cm is equal to 1 million cubic centimeter. So, pwede natin makancel ang cubic centimeter at ang matitira na lang ay cubic meter. So, 300 divided by 1 million times 1 is equal to 3.3 times 10 raised to negative 4. Natitira na lang is cubic meter. Or, kung hindi natin isa scientific notation, we have 0.0003. Ano ba? 0.003. Yes, 0.003 cubic meter. So, na-convert na natin ang cubic centimeter sa cubic meter. So, ang volume na is 3 times 10 raised to negative 4 cubic meter or 0.003 cubic meter. So, 300 cubic meter is equal to 0.0003 cubic meter. So, yung mass 173 grams. We need to convert the grams into kilograms. Alam naman natin na in 1,000 gram, we have 1 kilogram. Para makancel yung gram-gram, is equal to 173 divided by 1,000. We have 0.173. Anong unit nga natitira na lang is kilogram. So, na-convert na natin ang 173 gram sa kilogram na 0.173 gram. So, pwede na natin kunin yung density ng oil. So, rho is equal to M over V. M is 0.0003 cubic meter. Oh, mali. Mass pala. We have the mass na 0.173 kilogram and the volume na 0.003 cubic meter. We have 0.173 divided by 0.0003. We have 576.66 kilograms per cubic meter. number 2 question, 2 problems for you guys. Sagutan niyo siya habang sinasagutan ko siya dito. Pwede niyo siyang i-post para sagutan ninyo at i-play niyo na, kapag may sagot na kayo, i-play niyo na lang para makita kung tugma yung sagot natin. Oh, your battery is running low. Repeat question. Power bank. Charger. So problem number 1. 315 ml of liquid and the mass of the liquid is 0.197 kilogram. What is the mass density in SI units? So, tinatanong na naman dyan ang density ng density in SI units na kilogram per cubic meter. We have the volume na 315 ml and the mass na 197 kilogram. Hindi na natin kailangang i-convert yung kilogram kasi sabi niya din, SI unit, ang unit ng mass is in kilograms, so hindi na natin kailangan i-convert to. Ang i-convert na lang natin dito is yung 315 ml. Kasi diba ang unit ng volume is dapat naka-cubic meter or cubic centimeter. And nakalagay din naman doon na SI unit, so i-convert natin itong ml sa cubic meter. Gaya ng kanina guys, multiplied by, in 1 ml, we have 1 cubic centimeter. 1 ml, we have 1 cubic centimeter. Para ma-cancel out natin yung ml, dapat nakalagay siya sa baba. Cancel out is equal to 315 ulit. 315, ang natitirang unit is cubic centimeter. So, cubic centimeter. Kailangan na natin siyang i-convert sa cubic meter. So, times, in 100 centimeter, we have 1 meter. Hindi na natin ulit nakakancel ang cm sa cubic centimeter. So, kailangan maglagay ulit tayo ng sa parenthesis, cubic dito. So, is equal to 315 cubic meter times multiplied by 1 meter cube 100 cm times 100 cm times 100 cm is equal to 1 million cubic centimeters. So, pwede natin siyang i-cancel out ulit. Cancel. Ang natitira na lang is cubic meter. So, 315 divided by 1 million. 315 divided by 1 million. We have 3.15 times 10 raised to negative 4. Ang natitira na lang is cubic meter. Kung gusto nyo hindi naka-scientific notation, we have 0.000315 cubic meter. So, ito na ang volume natin. So, in 315 ml, we have 0.000315 cubic meter. So, pwede natin i-complete ang density. Rho is equal to mass over by volume. Mass 10.197 kilogram divided by 0.000315 cubic meter. We have 0.197 divided by 0.000315, 625.39.39 kilogram per cubic meter. So, example. So, ito na ang density na nanakap SI unit or the basic SI units. Kilogram, 625.39 kilogram per cubic meter. Example number 2. Problem number 2. What is the mass of air that fills a cube room that measures 8 meter and the density of air is 1.29 kilogram per cubic meter? So, hindi natin hinahanap ang density dito. Hinahanap na natin dito is the mass of the air. So, ang given natin is the density. The density na 1.29 kilogram per cubic meter and the volume na 8 meter. Alam naman natin na ang meter is not a unit for volume but it's a unit for length. So sabi doon kanina, fills a cube room. So ang formula for volume of a cube is volume of a cube is equal to S3. Halimbawa, ito yung volume, ito yung cube. Cube. So, ito yung cube natin. So, ito yung cube natin. So, S. So, ang kaya na doon, room that 8 meter. So, 8M. So, 8 times 8 we have 512, tatlong M, so cubic meter. So ang volume ng cube is 512 cubic meter. Cubic meter. Ang hinahanap natin is the mass. So ano ulit yung kanina? Para yung formula ng mass is M over T multiply E B. So M is equal to density multiplied by the volume. So M is equal to T multiplied by volume. So the density is 1.29 kilogram per cubic meter multiplied by the volume na 512 cubic meter. So, cancel yung cubic meter para matira na lang ay ang kilogram. So, 1.29 multiplied by 500 grams is equal to 660.48 kilogram. Kilogram ang unit niya kasi yun na lang natira at ang unit ng mass that ay kilogram or in gram. So this is the answer for the mass of the air that fills a cube room that measures 8 meter and the density of air is 1.29 kilogram per cubic meter. So that is my report for the mass density under density and properties of fluids. And again, I'm Jamaica Guittu, BSN 3B.
Hi, good afternoon. I'm here to discuss about specific weight. Specific weight is also known as unit weight or weight density, defined as the ratio of the weight of the fluid to its volume. The symbol of a specific weight is Y or gamma. The unit is Newton cube per meter and is mathematically written as specific weight equals weight over volume, where the W is weight of the fluid and the V is the volume of the fluid. Since weight is equals to mass times gravitational acceleration and mass over volume is density, we derive another formula for specific weight, which is gamma is equals to density times gravity. We have here our first example, which is the water. Water has a density of 1000 kg per square meter and the gravity is 9.81, which is the constant value of gravity. So gamma equals Pg, substitute P with 1000 and G with 9.81, we get 9,810 Newton per meter cube. We have another sample problem here. A carbon tetrachloride has a mass of 500 kg and a volume of 0.315 meter cube and is placed in a container. Determine the specific weight. First, find the given. M or the mass is 500 kg and the volume is 0.315 meter cube. Since the density is missing, find the density first. And the formula for density is P equals M over V or mass over volume. Now substitute M to 500 and V to 0.315 and we get 1,587 kilograms per meter cube. After finding the density, proceed in finding the specific weight. Gamma is equals to Pg or density times gravity. Next is substitute the density, which is 1,587, and the G, the gravitational acceleration, the constant value is 9.81. And we get 15,568 Newton per meter cube. And that's the specific weight of the carbon tetrachloride. Another sample problem, calculate the specific weight of 0.001 meter cube of liquid which weighs 8 Newton. Given weight is 8 Newton and the volume is 0.001 meter cube. Based on the problem and the given, ito po ang gagamitin nating solution. Specific weight equals weight over volume, substitute weight with 8 and volume of 0.001, we get 8,000 Newton per meter cube. Another problem, calculate the specific weight of 6 meter cube of oil which weighs 47 Newton. Parang the same lang. Nag-substitute lang. Okay? So, the given are weight which is 47 Newton and the volume is 6 meter cube. Same solution. Specific weight equals weight over volume. Substitute weight with 47 and the volume with 6 and we get 7.833 Newton per meter cube. Another sample problem, a reservoir of glycerine has a mass of 1,200 kilograms and a volume of 0.952 meter cube. Find the specific weight. The given mass 1,000 kilogram or 1,200 kilogram and the volume is 0.952 meter cube. Since hindi po given yung density, siya po yung una nating hahanapin, which is P equals mass over volume. Since yun naman din po yung given sa problem, mag-substitute na lang po tayo. P is equals to M mass 1,200 and volume 0.952, and now the density is 1,260.5 kilogram per meter cube. After finding the density, proceed in finding the specific weight. Y is equals to Pg, substitute the P 1,260.5 and the G, the gravity is 9.81. We get 12,365.55 Newton meter per cube. Take note lang, sa pagpilit po ng solution, mag-base na lang po tayo sa given problems and dun sa given na sinasabi dun sa problem para hindi po tayo malito. That's it. Thank you.
Next topic is relative density. Relative density or specific gravity is the ratio of the density of a substance to the density of a given reference material. Specific gravity for liquids is nearly always measured with respect to water at its densest. For gases, the reference is air at room temperature. RD is equal to P substance over P of reference liquid, where the P or the mass density of a reference liquid is always water, which has a mass density of 1,000 kg per cubic meter. The formula for relative density is RD is equal to P substance over P reference. You have two examples here and you can solve it. Just simply divide the P substance to the density of reference, which is the water. Since same sila ng unit, mag-cancel out lang tayo. Ang nakuha nating relative density ng silver is 10.5, means greater than 1 siya. The silver will sink to the water. And for the relative density of ice is 0.934, means less than 1, magpo-float siya sa tubig. And if the reference is air, same process lang siya gaya ng water, but the value of air is 1.29 kg per cubic meter.
In addition to what Christine already stated, relative density is the ratio of the density of a substance to the density of water. It is also known as specific gravity. Because it is a ratio, relative density or specific gravity is a unitless value. We also have example here, and ang isasolve naman natin is the P substance. It is given that the relative density of silver is 10.8. The density of water is 1,000 kg per cubic meter. What is the density of silver in SI unit? We all know that the formula of relative density is density of the substance or silver over the density of water. Now, we are going to rearrange the formula into density of silver is equal to relative density times density of water. Hence, the density of silver is 10,800 kg per cubic meter. The specific gravity of a substance tells whether the object will float or sink. It provides us the idea about relative mass or relative density. It is considered that if the given specific gravity of a substance is below 1, then it will float, and if it is greater than 1, it will sink. Based on the picture below, as you can see, on the left side we have steel, and on the right side we have wood. Comparing the two objects, the steel has 7.8 relative density, while the wood has only 0.5 relative density. Therefore, the steel sinks in the water, whereas the wood floats.
Okay, let's talk about viscosity. Viscosity is the important property of fluid while analyzing the liquid behavior and fluid motion near solid boundaries. Clearly, the viscosity of a fluid is the measurement of the resistance for gradual deformation due to shear stress or tensile stress. As we know, that the shear stress resistance in a fluid is due to its intermolecular friction exerted. It happens when layers of fluid attempts to slide by one another. Thus, we may say that viscosity is the measure of fluid's resistance to flow. So, ang viscosity daw is ang measurement ng fluid pag nagflow siya, resistance to flow. Tapos, viscosity is a concept where fluid shows a struggle against a flowing which is being distorted due to extensional stress forces or shear stress. Diba sinabi ko kanina? There are two related measures of fluid viscosity. First is the dynamic viscosity and second is the kinematic viscosity.
Next topic to be discussed is Newton's law of viscosity. Dynamic viscosity is a measure of internal resistance. Dynamic or absolute viscosity is the tangential force per unit area required to move one horizontal plane at a unit velocity while maintaining a unit distance apart in the fluid. The application of dynamic viscosity is to determine the characteristics of a fluid. It is frequently utilized in designing of pipes and pumps because viscous fluids can cause damage to pumping system, mostly in high fluid, low conditions. Overall, the shearing stress between the layer of laminar flow moving in straight parallel lines can be defined for a Newtonian fluid, as shown in figure 1.5. There are two types of fluid flow, laminar and tubular. Sa laminar flow, na-move siya horizontally, tapos smooth lang and slow, kaya straight lang siya. And sa direction of flow at every point remains constant. Sa turbulent flow naman, siya yung mas complicated kasi irregular yung movement niya pa. Tapos, nag-move siya horizontally and vertically. Kaya siya nagsuswirl. The equation of viscosity, T equals mu du over dy, wherein yung T is shearing stress in fluid. Tapos, ang unit niya is N over meter squared. Furthermore, yung parang U is siya yung dynamic viscosity of fluid. Ang unit rin na ginamit is N, S over meter squared. Moreover, yung DC, siya yung unit velocity, tapos ang unit niya is meter per second. Another one is yung dy, siya naman yung distance between layers, kaya meter ang kanyang unit. Lastly, yung y equals du over dy, siya yung shear rate. Unit niya is s raised to negative 1. Pagkuha ng shear rate, rs equals du over dy ang formula niya. Then sa shearing stress, T equals rs, ang formula sa paggamit ng shear stress equals shear rate times dynamic viscosity.
Okay, let's move on to the formula of dynamic viscosity. But before that, my name is Alexa Marie M. Pilier, BSE 3A, presenting the formula of dynamic viscosity. As we can see above, this is the equation or the formula of dynamic viscosity, in which the dynamic viscosity is equal to the shearing stress divided by the shearing rate of dynamics. For the shear rate, this is the velocity of the upper plate in meter per second divided by the distance between the two plates in meters. Then the shearing stress is the N per meter to the second in fluids is equal to the shear rate dynamics. So let's try an example. A fluid with a shear rate of 0.5 per second and the shearing stress of 0.76 N per meter raised to the second, according to its dynamic viscosity, to which one of these fluid correspond. So we have the choices of A. Water with dynamic viscosity of 1 Pascal S. B. Air with dynamic viscosity of 0.018 Pascal of S. And C. Mercury with dynamic viscosity of 1.526 Pascal of S. So for the solution, let's first calculate the dynamic viscosity using the following formula and using the given values. So dynamic is equal to the shearing stress divided by shear rate of dynamic. So our shearing stress served the 0.76 N per meter raised to the second, and our shear rate of dynamic is served as the 0.5 per second. So let's divide these two. So we will get the 1.52 Pascal of S. So therefore, it is clear that the mercury fluid will correspond to this fluid.
So hi everyone, I'm Ariel Dela Cruz, and for today's lesson, another type of viscosity ang ating i-discuss. Ito nga ay ang kinematic viscosity. So we denote kinematic viscosity as mu, or para lang siyang yung cursive na letter V, and it should be look like this. So by definition, we say that kinematic viscosity is the ratio of absolute or dynamic viscosity of the fluid to its density. So to put this into formula, we say that kinematic viscosity, or the mu, is equals to mu divided by rho, or fluid density. So in units, or yung resulting units na gagamitin natin, for SI, we have here meter squared per second. Sa metric naman, square centimeter per second, or we call this as the Stoke. Sa English naman, it's the square feet per second. So important notes lang guys, 1 Stoke is equivalent to 0.0001 meter squared per second, or 1 times 10 raised to negative 4 m squared per second. So for you guys to understand more about our topic, kinematic viscosity, we prepare here 2 sample problems that we are going to answer so that you can understand more about our topic. So let's start. So ito yung given natin sa problem 1, which is ang absolute dynamic viscosity natin, or yung mu, is 0.67 Newton second per meter squared. At ang ating fluid density, or yung rho natin, is 10 kg cubic meter, at ang hinahanap natin ay ang kinematic viscosity. So gagamitin natin ngayon yung formula, which is the kinematic viscosity is equal to mu all over fluid density. So magiging kinematic viscosity is equals to 0.67 Newton seconds per meter squared all over 10 kg cubic meter. So by the use of calculator, i-compute natin to. Kinematic viscosity is equals to 0.67 Newton second per meter squared all over 10 kg cubic meter is equals to 0.67 meter squared per second raised to negative 1. So yung kinematic viscosity natin is equals to 0.67 meter squared per second raised to negative 1. So for problem 2, si Joyce naman ang mag-explain. Thank you!
Okay, for sample problem number 2, we have here, calculate the density of the fluid having an absolute viscosity of 0.89 Newton second per square meters and kinematic viscosity of 2 meters square seconds raised to negative 1. So, dito guys, or class, ang missing dito is ang density of the fluid. So, ang given natin dito, absolute viscosity is equals to 0.89 Newton second per square meters. Tapos, ang viscosity natin is 2 meter square seconds raised to negative 1. So, yun yung given. So, ang missing natin dito is yung density. Sabi niya dito kasi is calculate the density. So, ang formula natin is baliktarin lang natin. So, kung sa sample number 1, ang missing doon is yung kinematic viscosity. Ganun lang din sa Q2, which is, ang formula sa kinematic viscosity, V is equals to absolute viscosity over density. Tapos, dito naman sa Q2, density is equals to absolute viscosity over kinematic viscosity. So, ang formula is P is equals to 0.89 Newton seconds per square meter over yung kinematic viscosity natin, which is 2 meter square seconds raised to negative 1. So, P is equals to 0.445 kilogram meter cube. Therefore, the density of the fluid is 0.445 kilogram meter cube.